Here are the Mod 15 Part 1 notes. This is page 8. So example 10. In our Harvard problem, suppose that the probability in our Harvard sample mean was as extreme as it was. So when we took a sample, our average was way different than our population, assuming the null hypothesis is true. It has crossed our threshold level, which means it's living in the tail. To what type of variation do we attribute the difference we found between the Harvard sample mean IQ and 100? These are due to systematic variation. Okay, now let's see if we can make that make more sense down here. We're going to draw a picture. So the decision rule, which means when we reject or fail to reject H naught. So we've got reject H naught or do not reject H naught, fail to reject. I think what makes it weird is it feels like we've got a double negative, and we do, but we don't ever say we're going to accept one of our hypotheses. We do not ever accept H naught or do not ever accept our alternate hypothesis. We reject or fail to reject. Okay? So the decision rule tells us whether to reject the null hypothesis or not. Okay? So we've got the p-value approach and the classical or critical value approach. So let's take a look at these. So if I am drawing my normal distribution, okay, I could have a z-score here. I guess I'm drawing this as a two-tail test. Here is every z-score cuts off an alpha level. Okay. So this z-score has an alpha or a percentage associated with it. Anything that lands in a tail, whether it's a right tail or a left tail or a two-tail, we reject H naught. So think about what that means. That means that the values that we found are far enough away from our population mean or proportion that they are in that little 1% in the tail or 5%, whatever our alpha value is. Okay. That means we want it in real words. Ooh. We are too far away from our normal or expected population values. Okay, so this is where my p-value, if I have a value in here, I may have a probability or a p-value of 0.002, definitely less than my alpha of 0.01 or 0.05, whatever that is. Okay, so our p-value is smaller than our alpha, and our alpha is cutting off those tails. If the p-value is greater than alpha, again, I'm going to go two-tail. Here is the z that cuts off some percentage, some alpha. So I said I was just going to do one, but really, the only difference between the p-value method and the critical value method is with the p-value method, we're using the alphas. With the critical value method, we're using the z-scores. So here, if the p-value is greater than alpha, it lives in here. Oops. which means it's not in the tail. So that's within a reasonable distance. Distance in quotes. From our population, mean, or proportion.